The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. Welcome guys. In this video, we're going to be solving this very problem. So I have to find the Fourier series of that very function. So let's get started. Remember to hit the subscribe button, like this video and comment. Leave a comment, say something nice. So the first thing we want to do is to find our A naught. So A naught is 1 over pi integral from minus pi to pi of f of x dx. So that's my A naught. That's A naught. Now this will be 1 over pi integral from, if you notice, the interval is from minus pi to pi, but there's a split in between. So we have minus pi to 0 and 0 to pi. So this our interval will then become minus pi to 0 plus, there will be another integral, 0 to pi. That's how it's supposed to be. Then put a bracket because the 1 over pi should multiply everything. Then we have f of x dx and f of x dx. The d I should be writing should be yeah. Okay. So this is what we have. Now the next thing I want to do is to put my f of x value. So this will be 1 over pi. Then we have the integral from minus pi to 0. Now f of x, when it's minus pi to 0, f of x was 0. So this is 0 dx plus the integral from 0 to pi. And what is f of x here? F of x here is just x dx. So this is what we have. This is what we have. All right. Now, if you have to integrate 0, the integral of 0 is still 0. So this is just gone. So take note, when we're solving other part of the equation, I'll just abandon this part. I'll just ignore this part. Because if the function is 0 at this interval, that means every single thing will be giving me 0. So I would always ignore it. So I would only be using this interval and the x. So this is the only useful guy. So this will be 1 over pi. Then we have the integral from 0 to pi of x dx. Now this is 1 over pi. Now if you integrate x, you're going to have s squared over 2. Remember that there's a 1 here. So when you say 1 plus 1, you get 2. Then you put your interval 0 to pi. All right. Now we kind of know that this over 2 is a constant, so you can bring it out. So this is 1 over 2 pi. Then what's left is s squared within this interval. So since we have only s squared remaining, let's put in our limits. So we're going to have the upper limit will make it pi squared, and the lower limit is 0. So that will be 0 squared. Because for x, anywhere you see x, we're going to put this pi and this 0. So the first time x was pi, second time x was 0. And this will be 1 over 2 pi. Then what will be left here will just be pi squared. Because this 0 squared is just 0, so it's gone. Now, pi squared over pi will give us pi. So this is basically pi over 2. That's what I'm basically going to be getting. Because this pi, we cancel out this pi squared, so one part of it will be remaining. That's why we have pi over 2. Now the next thing to find is a sub n. Now a sub n is 1 over pi, integral from minus pi to pi of f of s cos nx dx. Alright, so this would be 1 over pi, integral from minus, okay, now remember I said we're going to skip the minus pi to 0 because the function was 0 here. Since the function is 0 here, we're going to skip it. So let's go to 0 to x. I'm just going to go to 0 to x. Okay, sorry, 0 to pi. So just 0 to pi. And the f of x from 0 to pi is x. So f of x was x. Then you put your cos nx dx. All right. So this is 1 over pi. Now, to integrate this, we need to use integration by parts. And there's a shorter way to do that. So what I have to do is to write my x. So write your x. Differentiate x, you will get 1. So this is the differentiation part. They call this DI method. So this is differentiation. Next, we have cos nx. So cosine of nx, we ought to integrate it. So when you integrate cos, we get sine. So this will be sine nx over n, because you must always divide by the derivative. Now this whole bracket here, you're going to integrate it again. So integrate this value again. I think this one is too far. So integrate this value again. When you integrate sine, you get minus cos. Then this nx, you ought to what? Differentiate it. So when you differentiate this nx, you will get n. That n will come and meet the n that has been here to make it n squared. And then the correct sign for this is to say this first one is plus minus. And then your limit is 0 to pi. All right. So that's, you can actually use any method if you prefer. You can decide to do the integration by parts yourself. Your answer will still be the same. So this will be 1 over pi. Then we have, when you expand this will be x sine nx all over n. Minus times minus is plus cos nx all over n squared from 0 to pi. All right. Now the thing about sine nx within this interval is the value would always be 0. If we should put pi here, sine n pi is 0. Yeah, let me do something here. Sine n pi is 0. Sine 0 is still 0. So basically, everything here will just be 0 because of the interval. So we have only the cosine part. Now for this cosine part that we have, this n squared is a constant, so I can bring it out. The n squared is a constant, so I can bring it out. So this will become 1 over n squared pi, because the n squared is coming out. So we're going to be having cos nx remaining from 0 to pi. So this is 1 over n squared pi. Now anywhere we see x, we're going to put pi and 0. So this will be cos n pi minus cos 0. Because you need to evaluate the limits. So this will be 1 over n squared pi. Now, cosine of n pi has a special value. That special value is minus 1 to the power of n. And then minus cosine of 0 is also a special value. That special value is 1. And the thing here is, you see this bracket? This bracket has a particular behavior. So since this bracket has a particular behavior, remember that in Fourier series, we're having an infinite sum. And numbers can either be odd or even. They can either be odd or even. So when this happens, this bracket will behave in a particular manner. So let's find out. When n is even, let's see what's going to happen when n is even. So the bracket is minus 1 to the power of n minus 1. So we're going to pick minus 1. Let us pick an even number. Let's say 2. And then minus 1. Now minus 1 squared is 1. And then you have minus 1. So that's 0. So what does this tell me? This tells me that my a sub n will definitely be 0. Because if this bracket is 0, 0 times this will still give me 0. So whenever n is even, I'm going to be having 0 as my answer. Whenever n is even. Next, when n is odd. When n is odd. When n is odd. So let's see. So the bracket is minus 1 to the power of n minus 1. So this will become minus 1 to the power of the n value here. Let's pick an odd number, that's 1. And then minus 1. Now minus 1 to the power of 1 is minus 1. And then you have minus 1. So this is minus 2. So it means whenever you're picking an odd value, the bracket will always be minus 2. So that means my a sub n will then become the constant I have outside, 1 over n squared pi times minus 2. Because this whole bracket will become minus 2. So this is now minus 2 over n squared pi. And this would happen when n is odd. So you keep this value because we need to find b sub n. We need to find b sub n. All right. Now, if you notice, I did not graph that function. I already know that it is neither even nor odd. I kind of pictured it. That is why I made a video about how to sketch functions. So I already have a picture of what this thing will be. So it's not going to be even or odd. It's a very weird function. Okay. So right now, let's find b sub n. So b sub n is 1 over pi, integral from minus pi to pi of f of x sine nx dx. So that's what we have. So this will become 1 over pi, integral from, if you notice, I said let's leave this one that has 0. Let's only use the 0 to pi. This will be 0 to pi. Then the value of f of x there was x. So this will be x sine nx dx. And this is where we now do integration by parts again. So let's integrate by parts. So this is 1 over pi. Now, to integrate this, I use my DI method. So I'll write x, so write x down, then differentiate x until you get 0. So when you differentiate x, you basically get 1. So I'm done, because if I differentiate 1, I'm going to get 0. So I shouldn't be doing that. Now, this is sine nx. I'm going to integrate sine nx. So to integrate sine nx, this will be minus cos nx over n, because you must always divide by the derivative. Now, this same bracket here, you're going to integrate it again. So integrate this minus cos. Write your minus first. This cos will give us sine nx over, when you differentiate the nx, you're going to get n. That n will come and meet this very n to make it n squared. Then the correct sign is this is plus and this is minus. And then your limit is 0 to pi. So that's what we have. Now let's simplify this bracket. Let's simplify this bracket. So this is 1 over pi. This will then become minus x cos nx over n. Minus times minus is plus sine nx over n squared from 0 to pi. Now earlier on, if you notice, I said that this sine nx will give you 0. Because when you put in your limits, sine n pi is 0, so it's just gone. Just throw it away. So what will be remaining will be this very one. So this will be, let's bring out the constant. The minus is a constant, the n is a constant. So this will be minus 1 over n pi. The one will be left to be x cos nx from 0 to pi. All right. So what I'll do next is, anywhere I see x, I'm going to be putting pi. Anywhere I see x, I'm going to be putting pi. So this will be minus 1 over n pi. And so this is x, so this is pi cos n pi minus 0 cos 0. Okay, already you know this one will be 0 because 0 times cosine, no matter what this value will be, will just give us 0. All right. So this will be minus 1 over n pi into pi. Cosine of n pi will give minus 1 to the power of n. That's what it's going to give to us. And then this part is 0, so you can just throw this away. It has tried, so just throw it away. Now pi will cancel out pi. So this is minus 1 over n. And then we have minus 1 to the power of n. This is funny. This value, I want to do something about this value. So this is minus 1. This is also minus 1. So this is minus 1, this is also minus 1. This minus 1 is actually minus 1 to the power of 1. So using the laws of indices, this will be minus 1 to the power of 1 plus n. Or you can say n plus 1, any of them. So let's say n plus 1 divided by n. So that's b sub n. Yep, that's what b sub n is going to become. So let me write out all of my coefficients. So a naught is pi over 2. A sub n is minus 2 over n squared pi, where n must be odd and it's 0 otherwise. Then b sub n is minus 1 to the power of n plus 1 over n. So let me wipe the board and find the Fourier series expansion. So to find the Fourier series expansion, we're going to say f of x is equal a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx plus the sum from n equal to 1 to infinity of b sub n sin nx. Alright, so this will be a naught is pi over 2. So if this is pi over 2, and this one is also over 2, that means this will be pi over 2 times 2 because they are both divided. So they will both just marry themselves. Plus the sum from n equal to 1 to infinity. Now this a sub n is minus 2 over n squared pi. So I have minus 2 over n squared pi. But n must be odd. But I don't like writing this. I will show you what I would do for this part. And then cos nx plus the sum from n equal to 1 to infinity of this minus 1 to the power of n plus 1 over n sin nx. All right. This is the part where I simplify. So let's simplify. This will be pi over 4. The minus 2 is a constant. The over pi is also a constant. So let's bring it out. So this will be minus 2 over pi. Then the sum from n equal to 1 to infinity. What will be left? If minus 2 goes out, if minus 2 goes, what will be left is 1. So this is 1 over n squared cosine of nx. Now over here there's no constant. So this is plus the sum from n equal to 1 to infinity of minus 1 to the power of n plus 1 over n sin nx. So that's what I have. Now at this point, you always remember that this will be odd though. This will be odd. I always say something. So always make sure that the value you get here is always odd. Replace n with 2n minus 1. So if the equation would have said, give your answer in terms of n, I would replace this n with 2n minus 1 and replace this n with 2n minus 1, just these two. And that would be my final answer. But let us bring out some harmonics. Let's write out some harmonics here. So let's see how it becomes. So this will be pi over 4 minus 2 over pi. Now some harmonics here. Let n equal to 1. So this will be 1 over 1 cos 1x, which is just cos x. Next will be plus 1 over 3 squared. You can see that I did not put, after n equal to 1, I went to n equal to 3. I did not go to n equal to 2. I just went to what? 3. Because when it's 2, remember that it's going to be 0. So 2, because we're only picking the odd values. Cos 3x. And then plus 1 over 5 squared cos 5x. Now we're not really going to continue until infinity because we can never get to infinity. So plus, you're going to end here and close up your bracket. Now the next part, we're going to be saying that this item we have here will be plus, let's just open up a bracket. We can't really do without it. So there's no condition for this one. There's no condition. So n is equal to 1. Let's put that 1 here. So minus 1. If you say 1 plus 1, you'll be getting 2. Minus 1 raised to the power of 2 is 1. So everything will just be 1 over 1 sine 1x. So that's just sine x. That's just sine x. And then the next one will be n equal to 2. So you put 2 here. 2 plus 1 is what? 3. Minus 1 to the power of 3 is what? Minus 1. So this will be minus 1 over 2. Because your n is 2, remember, n is 2. Then you have sine 2x. Then the next will be plus 1 over 3 sine 3x. If you do this after the first 2 times, you will see that there's a pattern. Now I said it's plus 1 over 3 because when n is equal to 3, 3 plus 1 is 4. Minus 1 raised to the power of 4 is positive. So that's why I said plus 1 over. Remember that n is what? 3. So this will be 3 and this will be 3. Hold on. Let me just write one more. Now, when it comes to this other one, this will be minus 1 over 4 sine 4x. And then you end it. This will just be the answer. Yeah, so when you are asked to expand it, this will just be the answer. Now, what if I was asked to leave my answer in the nth term? I will say this is pi over 4 minus 2 over pi. Then the sum from n equal to 1 to infinity. Now, since this is always odd, I'll say this is 1 over 2n minus 1 all squared cosine of 2n minus 1 all, x, and then plus the sum from n equal to 1 to infinity of minus 1 to the power of n plus 1 over n sine nx. Yep. So this will be the answer in terms of n, then this will be the expanded form of it. And with this, I can now end this video, so we go to the next one. There are lots of videos here for you. So let's see in the next one. Bye.